Let's take a look now at a hypothesis test specifically for the mean and the median. Now, consider the following data, which consists of the time it took 15 students to complete an in-class quiz. There is evidence to suggest that the typical time it takes to complete the quiz is greater than, that's kind of important, greater than 10 minutes. You may want to pause the presentation and take just a moment to enter that data into your calculator. We will be using it for a test, for the hypothesis test for both the mean and the median. We're going to use it for both of these tests. Okay, I'm assuming that you did go ahead and pause the presentation. You have that data available to you in your calculator. I have it in L1 if you want to follow keystroke by keystroke what I'm doing. When we're doing a hypothesis test, there's certain logical steps that you should probably think about taking. The very first thing that you want to do is you always want to start off with identifying the parameter of interest. In this case, if we're talking about the mean, it would be mu. If we're talking about the median, it'd be theta. The next thing we want to do is state both the null and the alternative hypothesis. So we want to state both what the null and the alternative hypothesis is. And then we want to identify the appropriate test that we're going to use, because there are several tests for hypothesis tests that we will be working with. Once you identify the test that you want to use, now go ahead and state all the assumptions. Because if the assumptions that are needed are not satisfied, you need to think about doing a different test. You need to make sure that the test that you're going to be using is in fact appropriate for the data that you have. Next thing you're going to do is actually run the test, which means you're going to calculate the p-value. We will be using the p-value to actually make our decisions. And then once you have that p-value, you're going to state what your decision is. State your decision, which means you either reject or fail to reject the null hypothesis. And then finally, state your conclusion. In English, that's some type of English statement that confirms that you do have enough evidence to suggest whatever it is that your research hypothesis was stating, or you don't have enough evidence to suggest that. Okay, now looking at that data, let's start off and complete a hypothesis test specifically for the median. So the very first step is we want to identify the population parameter, which if we're talking about the median, in this case, we're actually talking about theta. That's the median. And notice this is about the population parameters. There's no statistics going in here. The next thing we want to do is state the null and the alternative hypothesis. Well, the null hypothesis is going to be a statement of the status quo, which is theta is equal to 10 minutes. And the alternative hypothesis, the research hypothesis, is going to be that theta was greater than 10 minutes. Remember, the question was, is there evidence to suggest it takes students longer than 10 minutes? The longer than 10 minutes is theta is greater than 10. That's the research hypothesis. That's the alternative hypothesis. Okay, step 3 was identify the appropriate test. Well, we're talking about the median, so we're going to use a sign test. And then the next thing would be to talk about the assumptions. And the assumption is pretty simple here. Remember, the sign test is actually a non-parametric test. We typically use this when the assumptions to do a t-test are not satisfied. So the assumptions here are very, very minor. And really, the assumptions are no more than what they are for every test. And that is that the sample is representative of the population. And this is really a standard assumption for everything we do. If our sample is not reasonably representative of the population, then why are we even working with the sample? Now, if we're looking at a t-test, we'd have to consider the normality of the data and so forth. So the assumptions are definitely more detailed, more work to do whenever you're dealing with a parametric test as compared to a non-parametric test. So now we want to actually calculate the p-value, which means we want to do the sign test. So I'm going to bring up my calculator, go to Program, and I need to go down and look for, let me bring up that large screen so you can see. There we go. Sign test. Not sign rank, but the sign test. Select Enter. I'm going to hit Enter again to run the program. And what's the null median? Under the null hypothesis, it's 10. What's the alternative hypothesis? The alternative hypothesis was that it's greater than 10. See right here is greater than option 2. So we will select option 2. And where's my data? My data is in L1. So I'll tell it second 1. Enter. Now, all this information here you should report. I require my students to report all of this because what this does is this will tell me what you did. And remember, I'm always looking for a reason to give you partial credit. So by giving me all this information, it'll help me, if your answer is wrong, it'll help me figure out what you actually did. Of primary interest is the p-value, which is 0.0176. So going back to my screen here, I'm going to say the p-value equals 0.0176. And also, like I said, you should list n equals 15, all the other information that's there, the number below, the number equal, the number above. Because what the sign test does is it looks to see how many values are above or below the null median, and it uses a binomial distribution to actually calculate the probability of that occurring. So all this information is useful in terms of me trying to give you partial credit. So it's really important. Now, based on this p-value, oh, there's one thing we skipped. I should have put in here. When we did step 2 here, we did the null alternative hypothesis. We should also specify alpha. And as a general rule, if a level of significance is not given, 0.05 is what we'll be working with. So alpha 0.05. Now, what we see here is that the p-value is less than alpha, actually less than or equal to alpha. Therefore, your decision is to reject the null hypothesis. Remember, rejecting is always in reference to the null hypothesis. So if I reject the null hypothesis, the alternative is what's left. So my conclusion is there is enough evidence to suggest it takes more than 10 minutes. I kind of ran out of room here, but I should say it takes more than 10 minutes to complete the exam or the quiz. So the p-value is small, so we rejected the null hypothesis in favor of the alternative. So the conclusion is really nothing more than a statement of the alternative hypothesis in English. That's what the step 7 is. Okay, now I'm going to do the exact same process, only this time I want to talk about the mean. So, what's the parameter of interest? If I'm talking about the mean, what parameter am I interested in? Well, that's mu, which is the mean. The null hypothesis would be that mu equals 10, and the alternative hypothesis would be that mu is greater than 10. See, this is the exact same thing we just did with the median, only this time specifically we're interested in the mean. Now, what test do we want to use? Well, if we're talking about the mean, we want to use the t-test. So we have to deal with the assumptions for the t-test, and the assumptions is that the sample came from a normally distributed population. So in other words, the population is distributed normal. And how do we do that? Well, there's two routes that we typically take. Number one, if the central limit theorem applies, then we don't worry about it. and we say, yeah, just the CLT applies. But in this case, n's 15. We need at least 30 for the CLT to apply. So what I need to do is take a look at a normal plot. So I'm going to come back to my calculator, go back to Program, and see right there, option 6 on my calculator is norm plot. I'm going to run it. The data is stored in a list, so that's option 1. And now where's the list? Well, it's in L1. Hit enter. And there's my normal plot. Now, this is not very normal. There are some issues here. All this stacking up over here, this gaps and so forth, this data looks more skewed than anything else. So if we had done this first, we would have said, you know, the assumptions are violated. This looks like a gross violation of the assumptions. So the next step would be to go back and do the same hypothesis test for the median. So let's go back here, and what I'm going to do is I'm just going to draw quickly a rough diagram of this normal plot. So it kind of looked something like this. There were a couple up here, some stuff like this, and kind of stacked up. That's not the best picture in the world, but it's close enough that when I look at this for my students, I say, yeah, they actually did it. And see, this and this right here is an issue. So I would say that it's not normal. So then switch to the sign test. And actually do what we just did a minute ago. However, for mechanics only, just to show you the process, I'm going to go ahead and do a t-test. So let's just go ahead and do the t-test. This is only for mechanics only. In reality, if you saw data like this, you would not be doing the t-test. So let's go ahead and run the t-test and look for that p-value. So I will go to Stat, Tests, and option 2 right there is t-test. I'll select it. I have data. Mu under the null hypothesis, that's mu naught. That means what do you have for under the null hypothesis? That's 10. My data is in fact in L1. Frequency should stay as 1. And this is saying what's my alternative hypothesis? The alternative hypothesis is greater than. So I'm going to come over here, select greater than, and then calculate. This p-value is 0.0098, so I'd report the p-value. 0.0098. The decision would be to reject the null hypothesis because p-value is in fact less than or equal to alpha. And then the conclusion, I'm just going to say the same. Because it's the same conclusion we did when we did the sign test. So you can go back and take a look at your notes on that. It says the exact same thing. There is evidence to suggest that the mean really is bigger than 10. Now again, I want to point out that once we did this normal plot, we said, hey, there's an issue here. We said it is not normal. We would normally not continue and do a t-test. This is saying switch to the median. So I would come back and say, okay, this is actually the median theta. This is theta. I'd switch this to be the sign test. And essentially repeat exactly what we had just done the first time around when we did the sign test. Reported the appropriate p-value. And in this case, we would have come to the same conclusion.